So I want to go over our slopes and equations of lines, especially since this topic is always more difficult than most for most students. In fact, there are so many formulas in it and ways to do a problem that even I was confused when I took this class in the 1930s. So anyway, let's go over slope. Let's go over slope first. Slope. So the slope of a line we're going to consider to be the rise over the run. Okay, so how much you would have to go horizontally from one point to another, and then how much you have to go vertically. So the rise is the vertical and the run is the horizontal. So what I'm drawing right here is if you go from point A to point B, the run would go from A to this point right here, and then the rise would go up to B. So we label A, we're going to label A x1, y1. We're going to label B x2, y2. Okay, so the run piece I'm going to replace with x2 minus x1, and the rise piece I'm going to replace with y2 minus y1. Okay, so question might be, where do these come from? Well, before I get there, let's just define the slope. The slope we use the letter M for. Rene Descartes started that number system, the lettering system. He's the guy that said, "I think, therefore I am." A French guy in 1700s. Anyway, 1600s, sorry. Y2 minus y1 over x2 minus x1 is the slope. Okay, so this is the numerator is the rise, and the denominator. The numerator is the rise, and the denominator is the run. Okay, so you might be wondering where this y2 and y1 and x2 and x1, why these are here and here. Okay, let's just do an example with numbers and I'll show you. So I'm going to draw a line that is similar to that, and let's denote 2 points on there. Let's do it with numbers this time. So let's suppose that the first point goes out 1, and the second point goes out 5, it looks like. And that if the first point goes up 2, kind of looks like 2, maybe it's 3, anyway. And then it goes up 6. So we have 2, 6, I'm sorry, we have 1, 6 for the first point, 1, 2 for the first point, and then we have 5, 6 for the second point. Okay, now if I draw that same kind of triangle, like this, let me put the 5, 6 above it. 5, 6. And we put the 1, 2 above it. 1, 2. Then we see that the bottom side here, the horizontal side, that length is 5 minus 1. It's this number minus this number. And the vertical side is 6 minus 2. It's 6 minus the 2. Okay, 6 minus the 2. It's that length. So if we were to draw the axis over here, okay, like I did here, it would be the same kind of scenario but with letters. Okay, so this one has a rise of 4 and a run of 4. So the slope here is 4 over 4, which is 1. Anyway, so that's how it's obtained. Really all you need to know is this formula right here. Okay, y2 minus y1 over x2 minus x1. By the way, it's a common mistake to write x2 minus x1 over y2 minus y1. All right, so don't do that, please, because your slope will be the reciprocal of what it should be. Okay, so that's the slope. Now, there's a couple of special cases we're going to get to in a minute, but let's talk for a second about positive versus negative slope. Okay, versus negative slope. The idea here is if a line points upward from left to right, so we always read the line from left to right, just like you read a textbook or a book. If it goes up as you're going from left to right, it's positive. And if it goes down as you go from left to right, it's negative. Okay. And whenever you do the slope formula, you'll see that these lines are positive and these lines are negative here. We just did an example where the line, as you go along the line, as you're walking up the line from left to right, we saw that the slope was positive. Now let's see an example of where the slope might be negative. So I'm going to draw another line. Let's make it purple again. And let's suppose it has the point, I don't know, that looks like 1, 3, and suppose it has a x-intercept of, let's say that's 5, 0. So the slope, remember, here is y2 minus y1 over x2 minus x1. Now, it doesn't matter which point you choose as x1, y1 and x2, y2. You just have to be consistent. x1, y1. No, not consistent, x2, y2. You have to make sure that if you're going 2 minus 1, you go 2 minus 1 on the bottom as well. Okay? So y1, y2 is 3, y1 is 0, x2 is 1, x1 is 5. So this is 3 over negative 4. And you see it is negative. All right? So since we're going down the line, reading it from left to right, it has a negative slope. All right, so there's two special cases. So what about what about horizontal lines? Okay, so these have zero slope. One way that I remember this is that there's a 0 in horizontal. Okay, it's just a stupid way to remember it. But anyway, let's look at y. So y. Well, if you look at a horizontal line, all right, like this. Here's a point. Let's call that x1, comma. All right, so the y value is going to be the same for any point on the line. So let's suppose that this is, let's suppose that it hits at, well, let's just call it y. So x1, y will be the first point. Let's call it y1, just because we're used to that. y1. And then the other point, so that's at x1 along the x-axis. The other point will have a different x, so we'll call that x2, comma, and then it'll same y value, y1. So the slope here will be y1 minus y1 over x2 minus x1, and the top will be 0 over whatever this bottom is. So that's just 0. So we got a 0 slope out of this. I have a feeling that's a little too theoretical to really understand, so let me do an actual example. Okay, so suppose we have this line and one of the points is 3, 4, and the other point, we'll say that this is 4 here, and the other point moves along and it's 6, 4. So the y values are the same because as you go over and up and over and up, you're going up the same y value. So the slope here is, let's call these x1, y1, x2, y2. So it's going to be 4 minus 4 over 6 minus 3, which is 0 over 3, which is 0. So your slope is 0. And there you have it. All right, now the other special case is for, there's two special cases. The other special case is for horizontal, is for vertical lines. Okay, so vertical lines. Okay, so what I'll do is I'll just do a numerical example to show it to you. So these vertical lines have what's called undefined slope. And what's going to happen is that the denominator is going to be 0 under undefined slope. Okay, so it's going to be a number over 0. All right, the previous one, horizontal, was always it was always 0 over a number. Now, the bottom number can't also be 0, but you don't get to that until later. Anyway, so anyway, let's look at an example of one. So if you take a vertical line, and let's say we go over, let's say this point here, it's at 3. So let's say one of the points is 3, 1, and then another point is 3, 2. So the slope here is 2 minus 1, it's the difference in the y's, over the difference in the x's. And so this is 1 over 0, and this is undefined. Undefined. All right, so when the denominator is 0, the fraction's undefined, and so vertical lines have undefined slope. And there you have it. That's slope, basically. Now, before we get to lines, I want to talk about parallel and perpendicular lines. So, parallel lines. So here's some facts. All right. So parallel lines have the same slope. Parallel. Please spell parallel right, correctly. Parallel lines have the same slope. Same slope. The way you remember how to spell parallel is that there's two parallel lines in parallel. Okay, the reason they have the same slope is if you have two lines, then the rise over the run is going to be the same for both, okay, from one point to the next, as long as the points are above each other and below each other, okay. So the rise over the run is going to be the same. So the parallel lines are the same slope. Okay, the other one is perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. Negative reciprocals of each other. Now, the proof of this I could go into, but normally it's talked about later. So, for example, if you have line 1 has a slope and one of, let's say, 3 over 2, and line 2 has a slope of negative 2/3, then you can say that line 1 is perpendicular to line 2. Perpendicular means that they meet at a 90-degree angle. 90-degree angle between them. Okay. In other words, they meet like this, 90-degree angle. Okay. So we're going to get to that later with lines. Okay. Well, later happens now, so now let's talk about lines. Lines. So there are two formulas for lines. The first formula I want to talk about is, so let me just give you a little fact. So if you are asked to find the equation of a line, all right, the equation of a line, then you can use of a line, then you can use y minus y1 equals m times x minus x1, as long as the slope is defined, the slope m. Slope is not undefined. Undefined. Okay. So if it's undefined slope, okay. So in other words, so vertical lines can't use this formula because their slope is undefined. All right. So basically all you need for, oh, this is not x2, this is x1. Basically all you need for the equation of a line is the slope and one of the points. So m will be the slope, of course, and then x1, y1 is going to be, this is a point on the line. Okay. If you're given 2 points on the line, then you just find the slope from that, and that'll give you your m that you need. All right. So moving right along, let's do an example of this. So here's a little mini example. So it'll say like something like find the equation of the line through or containing the point, let's say 2, -3, with slope m equals, let's say it's 1/4. Okay, so you just use your formula. So I would recommend that you write this formula down as much as possible every time you need it, because this is a minus, because I want you to memorize this formula. Okay, I want you to memorize the slope one as well. There's only a few formulas in this class you have to memorize. That's one of them. Okay, so here we are. So we just plug in our points, basically. So I'll do the answer in red. Y minus y1, here's x1, and here's y1. Y1 is -3. So y minus -3. What is that? Y minus -3 equals m. M was 1/4. So it's 1/4 times x minus 2. So this, you get y plus 3 equals, and now I'm going to multiply that 1/4 through. So that's 1/4 times 2 is 1/2. Remember your algebra here, or your arithmetic. 1/4 times -2 is the same thing as 1/4 times -2/1, which is the same thing as -2/4, which is -1/2. And there you have it. So now I will always ask you to solve for y, unless it's a test that I don't make, which sometimes you might get that, but not normally in my class. So I'm going to subtract 3 from both sides to solve for y. So this is y equals 1/4 x. All right, now here we go. -1/2 minus 3 is the same as, I'm going to make the same denominator. -1/2 minus something over 2. This is 3/1. So 1 goes into 2 2 times, and 3 times 2 is 6. So this is -7/2. Remember, when you add two fractions, you add just the numerators and the denominator stays the same. So this is -7/2, and there's your line. Now, this is what's called slope-intercept form. And this is the way I want your answers to be. And I'll put that on the test. Okay, slope-intercept form. Now, while we're at it, the homework may ask for what's called, so slope-intercept form is this good old friend y equals mx plus b, where b is the y-intercept. Okay, so apparently whatever this line looks like, the y-intercept is -7/2. That's where it hits the y-axis. Actually, let's graph that right now, just real quick. So, and then I'll get on to the other thing I was going to talk about. So it's so let's graph it. So -7/2 is the y-intercept. So all right, -7/2. So the line is y equals 1/4 x minus 7/2. 7/2. So 7/2, -7/2 is also known as -3.5 when you do the math. So we go 1, 2, 3, 4. So it hits here. I'll draw it in purple. And now the slope is 1/4. So the slope is 1/4. That's the rise over the run. So I'm going to rise 1 and run 4. Go horizontally 4. Or this is not the scale. So I went up 1 and I go over 4. and then I draw another dot there. Okay, so this becomes this line right here. Okay, and so slope-intercept form gives you an easy way to graph the line. You just get the slope and the y-intercept, and you got it. Okay. Now, there's another form called standard form, which I don't like, but you're often asked to do the answers in standard form. And this is when you have some term, some number in front of x, a number in front of x, plus a number in front of y. Well, let me just draw it out. It's ax plus by plus c. Sorry, equals ax plus by equals c, where a, b, and c are numbers. So an example of this would be 2x plus 3y equals 4. It's a 4. Now, here's a caveat. A is a non-negative integer. Okay, you don't want a fraction there, and you don't want a negative number. So if we go back up to this other one, y equals 1/4 x minus 7/2. Let's convert it. So let's convert y equals 1/4 x minus 7/2 to standard form. Okay, so what you need is you need the constant on the left, sorry, on the right. So we're going to keep that, we're going to keep the 7/2 on the right. And I'm going to move the 1/4 x to the other side. So I'm going to subtract 1/4 x from both sides. Now here a is negative 1/4, and it needs to be a non-negative integer. So we'll multiply everything by a negative. So multiply by a negative. So I get 1/4 x minus y equals 7/2. When you multiply by negative on both sides, multiply each term by a negative. Okay, and now it needs to be an integer, and it's not. So if we multiply 1/4 times 4 over 1, we get 4 over 4, because you multiply straight across, and we get 1. So this is an integer. So what I'm going to do is I'm going to multiply by the denominator everywhere. So here we go. So 4 times everything. Let me rewrite it. This is 1/4 x minus y equals 7 over 2. And let's see what happens here. So I know that the 4 times the 1/4, that gives me just 1x. 4 times negative y is negative 4y. And then over here, I get 14, I think. So let's see how this happened. We did 4 over 1 times 7 over 2, which you can cancel the 4 and the 2. This gives me a 2 over here, which gives me 14 over 1, which is 14. Okay? All right, so you don't need to write 1 whenever you have it in front of a variable, so it's x minus 4y equals 14. There's your answer. Now, the reason why I don't like this way to put your answer is, the question is how to graph this. So if I give you a line just like this, how do you graph it? Well, you'll have to plug in points and stuff, or one way to do it is plug in points, or you'd have to convert to slope-intercept form. And why would you do that if you started out that way? All right. So if you just put it in slope-intercept form to begin with, that's that y equal mx plus b, you wouldn't need to worry about it. You wouldn't need to do this. But anyway, this is the standard form of the line. And then up here, where is it? This right here is the slope-intercept form of the line. Okay, and that's the line that has the point 2, -3, and the slope 1/4. Now let's do another example where you have maybe two points. Okay, this is a very common question I would ask on a test. All right, so another example. might be find the equation of the line. Equation of the line. Draw a line here. Equation of the line through the points. Let's say 0, 2, and 3, -1 again. Let's just do -1. -1. Okay. So we're going to use, I'll do the solution in red. We're going to use y minus y1 equals n times x minus x1. Okay, now we need the slope. We have x1, y1. x1's here, y1's here, x2 is here, y2 is here. Once again, someone could come along and say, well, I want to label it x2, y2, and x1, y1. That's fine. Everything will work out fine. No problem. So it doesn't matter how you label it. Just make sure it's not, you're not doing x1, x2, and y1, y2. It's the x coordinate, y coordinate, x coordinate, y coordinate. Okay. All right. Anyway, so we need to find slope. So the first thing we're going to do is we're going to find slope. Slope m. Okay. So we go m. And you're going to write this down every time you need it until you've memorized it. All right. So y2 minus y1 over x2 minus x1. So this will give us -1 minus y2. So y2 is -1 minus 2 over x2 is 3 and x1 is 0. So minus 0. So this is -3 over 3. Ah, this is nice. This is just -1. So -1 is my slope. So what I'm going to do is I'm going to take that and I'm going to plug it into that right there. And then I have my x1, y1 that I can plug in here and here. And I'll almost be done with this problem. So here we go. It'll be a little small. It'll be y minus y1 is 2 equals m, slope -1 times x minus 0. Okay. Don't ever plug in anything in for y and x. Okay. Those always, you leave those alone when you're finding the equation of the line. So we got y minus 2 equals -x plus 0. So y minus 2 equals -x. So y equals -x plus 2. We're going to add 2 to both sides, right? Add 2, add 2. Can't add the 2 and the -x, so it stays out. So this is my line right here. This is the equation of my line. Now what I want you to notice is that this 2, this is the y-intercept. Okay, the y-intercept. So when you graph it, this is only if y is by itself, okay? Can you make that the y, can you assume that's the y-intercept? So what we have here is we have 2 as the y-intercept, so 1, 2, it's right there. And then the slope was -1. So we can just say that's -1 over 1. Or you can actually say 1 over -1 is your choice. So let's just do the second one, rise over run. Okay. So we're going to take that 2 and we're going to rise and run this thing. So we're going to go up 1, over 1, like this. Wait, oh, back, wait, back up. The run is negative, so I'm going to go back 1. So go up 1, back 1. So maybe it ends up there. And then that's your line right there. No, that's not all. Hard to draw on a tablet. Like that. Okay. And so it's a negative slope. Notice that you're going down from left to right. Okay. From left to right. And the slope was negative. Sure enough, the slope was negative. So everything's working out great. Now, one last thing I want to show you is notice that the y-intercept is 2. It's where it hits the y-axis, x-axis. If you go back up here, when I pick the points, see how this 2 is in here? This is the y-intercept because the x coordinate is 0. When the x-coordinate is 0, that means you've gone over 0 in the x direction to get to the point. So remember how you graph points, you start at 0, and then you go either left, right, or left in the x direction. Well, if the point is 0, 2, you don't go anywhere in the x direction, you just go up 2. Okay, so if you're ever given a point that's 0, something, you'll know that that's the y-intercept. All right, so with that said, let's move on to other types of problems. So let me give you another kind of example. So example, it may say, this is typical of my test, find the equation of the line, can I draw that? The line through, let's pick a point, I don't know, -1, 6, and perpendicular to the line. Y, let's make it, let's put it in standard form, 3x plus 4y equals 1. So we need to find the slope. So so I'll do the solution in red. So we'll use the same formula, use y minus y1 equals m times x minus x1. I have students a lot of times complain that there's too many formulas in math, so I'm giving you as few as possible. Notice every time I say find the equation of the line, I'm writing this formula down. That's all you need, unless the slope is undefined. You need just use this every time. And then all you need to do is find the slope and plug in the point that's given. Well, here the slope isn't given, but you can find it by noticing that the line you need is perpendicular to the line given. So let's find the slope of the given line. First, so we're going to solve for y. Once y is solved for, that's your slope. That was up here somewhere. Y equal mx plus b. Where was it? Y. If it's in the form y equal mx plus b, that gives you your slope. So if you solve for y, your slope is the coefficient of x. So what we're going to do is we're going to solve for y here. So we have, start out 3x plus 4y equals 1. So I'm going to subtract 3x from both sides. So I get 4y equals -3x plus 1. I'm going to put the x first. And now I divide by 4 on both sides. Divide by 4 everywhere. And so I get y equals -3 over 4x plus 1/4. Some students will write -3x over 4. I invite you, don't do this, because I always say, you always assume that the coefficient of x is the slope, and you'll write that the slope is -3 because that's what's in front, but it's not. The coefficient of x is 3/4. Okay, so just be careful. Okay, get rid of that. Get out of there. So here, slope is -3/4. Now this line is perpendicular to the line we need. Okay, so what I'm going to do is I'm going to take the negative reciprocal of it. So the slope of the line we need is, okay, we're going to take -3/4. We're going to take the negative reciprocal, so I'm going to make it positive. And then I'm going to make the reciprocal out of that, 4/3. So negative reciprocal. So the slope of the line we need is 4/3. And now, part 2, so I found the slope. I'm going to find the equation of the line. Okay, so part 2, we're going to use y minus y1 equals m times x minus x1. Well, I know that the slope is 4/3, so I've got that. I know I don't plug anything in for y or x. So far I have this, and I just plug in the point for x1, y1. So the point was this point right here. So it was negative 1, comma 6. So I go back up, negative 1, and then 6. Remember, it was negative 1, comma 6. So this is x1, y1. And now you just solve for y minus 6. I always multiply the right-hand side through first. This ends up being a plus here. This is a plus. So this is, let me make that a plus first, x plus 1. So it's y minus 6 equals 4/3 x plus 4/3. And now we have to add 6 to both sides. Oh, fun times. So let's see, it'll be y equals 4/3x. And I think this is plus 22/3. Let's see how I get that. Let's use green. So let's move this over here. 4/3 plus 6 is the same as 4/3 plus 6/1, which is the same as 4/3 plus, now 3 is the common denominator. 1 goes into 3 3 times, and 6 times 3 is 18. And then 18 plus 4 is 22. Okay, that's how I got 22/3. And now that is the equation underlined. Now, one common mistake in these problems is the following. I see it all the time. It says find the equation of the line through the point and perpendicular to this guy right here, and you're supposed to find the slope. So there's a common mistake where the student will say the slope is 3. They'll take the number in front of x, but the slope is only the number in front of x, the coefficient of x, if y is solved for. So must solve for y first. Okay. Okay, and that's what we did. That's what we did. We solved for y, and then we got our slope. Okay. All right, so moving right along, let's look at another type of problem. Where are we at? Just go down. All right. So now let's look at another type of example. It could say something like find the equation of the line. Of the horizontal line. Find the equation of the horizontal line. Line through the point. I don't know, let's say negative 4, 2. Okay, so the solution is, first of all, horizontal lines have 0 slope. We know that from above. So we know the slope right away, 0 slope. It says 0 slope. So we'll use y minus y1 equals m times x minus x1, and we'll put a 0 in right here, 0. And now it gave us the point. Here's x1, y1. So you just plug in what you got. Y minus 2 equals 0 times x minus a minus 4. So it's y minus 2 equals, well, 0 times anything is just 0. So the left-hand side, the right-hand side is equal to 0. And now you just add 2 to both sides, and you get y equals 2, and that's your equation. So y equals 2 is the answer. Now, here's a little fact. If k is a number, it's a letter, but suppose it's a number, y equals k is a horizontal line. Okay? All right, now let's do another example that you might see in the homework, and also maybe on one of my tests. It'll say something like find the equation of the line, let's say the vertical line. All right, vertical line through, let's say 2, negative 3. Okay, so since it's vertical, the slope is undefined. Okay, so it's undefined. So what this means is we can't use this formula I've been using every time, y minus y1 equals m times x minus x1, because m is undefined, okay? So this isn't going to help us, okay? Well, it's vertical, so let's just draw it. So let's come down here and draw it. It's 2, negative 3 goes through it. I'm sorry, it goes through 2, negative 3. So I'm going to go over 2, down 3. So that's here. Here's 2, here's negative 3. And let me just draw a vertical line there and see what happens. So when I draw, this is on a tablet. When I draw the vertical line through there, what you'll notice is every time you go to a point on the line, you're going over 2. Okay? 2 something. This bottom one is 2, negative 3. Even up here, you're going over 2. Over 2. This is y, this is x. So it looks like, okay, so suppose this is 2, negative 1, this is 2, negative 2, and up here is 2, 2. Notice that all the x values are 2. So the equation of this line should be x equals 2, because x is always 2, and it is. All right? So let's give you a little fact here. The equation, so I'm sorry, if k is a number, the equation x equals k is a vertical line when you graph it. Is a vertical line. Okay, so please know this. All right, one last thing. This is parallel. No, that's it. Parallel and perpendicular lines. So going back up here, if I talked about parallel, if instead here I said find the equation of a line through negative 1, 6, and maybe this said parallel instead, then you would use the same slope here for the equation of the line. So you wouldn't need to do all this. You would just use the same slope. You would use negative 3/4 here, and you're done. So that's a little primer on lines and slope.